Hello and welcome to CSA's webinar series, CSA Cloud Bytes. Today's webinar, sponsored by Concourse Labs, is titled Security as Code, What's Real and What's Possible with Self-Service and Developer Speed Governance. A few housekeeping items before we start. Please enter your questions at any time during the presentation by using the question tab at the bottom of your screen. We have reserved time toward the end of this webcast to address your questions. Additionally, the slides from this webinar are not provided. However, there are additional resources in the Resources tab that you can download. And you can also access this recording at any time by using the same link to view the webinar again or share it with a colleague. I'm going to pass things over to Tony Karam, Senior Director of Product Marketing at Concourse Labs, to talk about today's presentation.
Great. Thanks, Brooke, and thanks everybody for joining us today. We've got a really exciting topic and a great presenter with us today. It's my pleasure to introduce you to John Stephen. John is, as Brooke said, the Chief Technology Officer at Concourse Labs. He has more than 20 years of experience in technology and product development and leadership. John has extensive software security experience, from managing security initiatives hands-on to cloud security, threat modeling, building security architectures, as well as risk-based security orchestration and testing. Prior to joining Concourse, John held previous CTO roles at places like Zero North, Digital, and Codascope. And John holds a true passion for software-defined security governance for the cloud. He co-authors the BSIMM study and serves as co-editor of the Building Security in Department for the IEEE Security and Privacy magazine. So with that, I will turn it over to John.
Hi, everybody. Good morning, good afternoon, good evening, whenever you're observing this. Pleasure to be with you today. As Tony mentioned, I think this is an interesting time, and I want to kind of get into why. Having gone through a few major technology and security revolutions, first the web, and then mobile and IoT, and now cloud. This time does distinctly feel very different, and I want to talk about how, as security practitioners, as security executives, we need to address that. And I want to reference the BSIMM study, the Building Security and Maturity Model, where we went out and we asked security executives, what are you actually doing? Not what are vendors trying to sell you, but what do you really do? And how do you do those activities? And I want to look at not only the opportunity we have as we make this technology change, but what we see people doing differently this time around that may be making them more effective. I think this is globally unique in terms of at least my career, in terms of a confluence of what we're trying to accomplish from a business perspective, as well as the technology opportunity. And that's going to come in the form of, governance or security as code. We'll talk about what that is. We'll talk about why self-service is an important touchstone for that, and how it focuses us. We'll look at what's available open source wise and how you build on it, and what you may want to add in addition to it. Where you'll struggle, and what are the hills to climb, and what you ought to be reaching for in terms of practical recommendations. So in terms of these sea changes, I mentioned the different tech stacks that we've been developing on over the last few decades. This time really is different, and it's the confluence of a bunch of sympathetic waves of change. For 2 decades, we've been talking about making software delivery more rapid. It's gone by a bunch of different names, first agile, then agility, then, continuous this or that. CI/CD, continuous delivery, continuous deployment. Really look at, the fact that we're trying to break down the barriers, between department and between process steps. Things that were hard gates are becoming soft and asynchronous. Everything is becoming more rapid in that regard. Change is happening faster, not only because of the change in culture that's happened above, but because more and more of what developers do or what engineers deliver is available in the form of open source. So not only is there a process wave and imperative for speed, but we're able to download and leverage more of other people's code that's become culturally acceptable. There are platforms and tool chains that really facilitate that. So you can self-service more of the aspects of the software lifecycle. You can self-service more coding and download and incorporation of code in frameworks. With the cloud, you get another big wave crashing, which is you can self-service infrastructure. So whereas you had to wait 3 months for somebody in IT to provision a database, now you can snap your fingers and get an RDS instance or similar in the cloud. That is a game changer as it pertains to the previous two. Security, let's skip over that one for a second. In terms of the control architecture, things like Kubernetes, things like the service meshes, which we'll talk about a bit more, platforms like OpenShift are giving people control over a broader range of the activities and capabilities they need in a software delivery, not just a software development or a deployment, but a full lifecycle software delivery capability. And what those technologies mean is that operators can reach back into development environments, reconfigure, recombobulate, and deploy and operate. It means that developers can reach into deployment and push things. All of these sympathetic waves, culture and process, open source, infrastructure and cloud, as well as control plane, are designed around one watch concept: self-service. It's now possible in some organizations for a developer to be a whole line of business on their own. The one area here that we've struggled with to keep pace is security and risk. Are we able to govern and apply proactively security controls or understand where exposure exists with the same level of self-service? The answer is no right now, and the answer is we need to be in order to keep up with the other sympathetic crashing waves. So security as code is the instantiation of security process, security tooling, security activities as declarative artifacts, configuration, but code if not, that allow us to do defect discovery or automated security control application in that declarative, in that configuration-based way, in the ways that we use configuration for incorporation of open source, configuration of development frameworks, orchestration and packaging, and then ultimately delivery. Security as code is a way, is the objective of it is to formalize all of those activities, manual processes, and the manual application or incorporation and operation of the security tools, again, as configuration. Think of everything you're doing in an infrastructure as code perspective to orchestrate use of the cloud and use of those assets, and ask yourself, could you do the same thing to your security tools and activities? So before we progress and talk about this, I think, Tony, you're going to set up
perfect.
See where people are at.
Yep. So John mentioned sort of infrastructure as code, and so we're very interested in learning more about usage around infrastructure as code and these software-defined tools. So let me fire up this poll. So everybody should be able to see this poll question on their screen. So I'll just read it. So what percentage of your organization's cloud services are provisioned using infrastructure as code? So things like Terraform or CloudFormation or similar software-defined tools. So it looks like the poll here will run for about another 30 seconds. So when you get a chance, please make your selection. It'll be really interesting to see, we've been running this poll in different forums, so it'll be really interesting to see what the results look like compared to some of the other audiences or forums that we've polled recently. It's about 10 seconds left, so if you haven't yet voted or made a choice, by all means, please do so. Okay, so I'm going to end the poll, and hopefully everybody can see the results.
Interesting. 25% or less is what 100% said in this audience. The last time we conducted this poll, we got a very sort of normal distribution around that curve. So studies showed 3 years ago that between 11 and 25% of people's total code bases were infrastructure as code. And that is in an open source space, what's publicly visible. In private repositories and enterprises, we think the number when studied is far greater. And not only that, but as much as 30 to 40% of the churn, in other words, what's being worked on, was the infrastructure as code commit to commit or release to release. And so what we see is that this is clearly a ascendant aspect of things. If your organization is still in a prototyping phase with the cloud, you may be doing things manually. What we see is that even if that's the case, people tend to snap over to much greater use of infrastructure as code once they've finished that prototyping phase, and they've come to grips with what they think are things like well-architected blueprints or standards, standard builds or standard configurations that they want to put guardrails on. So look for those numbers. In fact, in the last time we did this survey, what we found is that 40% of respondents overall, I can't remember the exact number, were between the 25 and 75%. 25 and 75% is infrastructure as code. So watch that number increase, rapidly when it begins to take off. And this is what we're seeing. In fact, when we went out in the BSIMM study and observed what security initiatives did, it caused us to conduct a compendium study because of how marked these trends were. So historically, we found that people were trying to automate what they were doing in development, and that begot, CI/CD. Because cloud and cloud development pipelines give you a greater automation over a greater piece of the lifecycle phases. We really looked to what was a kind of a DevOps 2.0, being able to stand up whole pipelines virtually in the cloud or targeting the cloud. And now we see people changing that over to their DevOps teams are not standing up those capabilities, but they're just documenting them as infrastructure as code. And developers are able to use that infrastructure as code to stand up their own pipelines, sometimes completely self-service, and sometimes completely in a SaaS-based model, like we see with use of the GitHub or similar platforms. And so what we see is that that touchstone of self-service went from just the way we develop to the way we develop and provision infrastructure to the way that the whole development lifecycle is managed, to developers and operators becoming self-service from cradle to grave in terms of the initiatives. And the more of that becomes self-service, the fewer touch points that security practitioners and governance has with the lifecycle. What would happen oftentimes when people develop their secure SDL is they would look for places that developers or some role would hand off to a different role, and they'd introduce a governance gate at that point. So, when design became code, you would look at a threat model or a design review. When code became binary, you would do defect discovery and static scanning. When the binary became deployed, you do penetration testing. Those points of exchange became opportunities for gates. As those points of exchange go away, because more and more of this is happening in a self-service fashion, the question is, what have we done on security? And the answer is, well, we really still, when we survey people, see them going from, there's something I artistically apply as a subject matter expert in security, to, can I find a way to get a tool to find the same thing? And then how do I go out and implement that tool in each of the development pipelines or the delivery streams that my organization has? That's really a security 1.0 mindset that has remained to this day. And it's at about the same level of automation we see between DevOps 1 and DevOps 2 here. Some organizations have really embraced the notion of federating. They said, look, I have 3, I have 10 security people in my group, but I have thousands of developers. I need to anoint development champions, and I'm going to spread that way. We'll let those developers receive training. We'll tool them up. We'll give them support in office hours, but they'll apply these governance gates for us in situ of the business unit or delivery capability. That's in some sense self-service, but it's not software defined. They're still reliant on those security champions. Security champions tend to have a 1 to 100 ratio with developers in large organizations, maybe 1 in 10, in very forward-thinking organizations. But again, that's still a human-limited process. We're not looking at the level of self-service that being able to snap our fingers and set up a delivery pipeline reflects when we have champions that have to go, review something or integrate something. And so the difference between these two levels of self-service and automation create what I call, a self-service or a risk gap. If developers can create ephemeral pipelines, I'm working with an organization that 3 years ago was standing up hundreds of ephemeral delivery pipelines per month. So security had no way to inventory or even see the existence of those pipelines, let alone the ability to go out and integrate a security gate into them. And so if this creates not only a gap in terms of the level of visibility and the level of coverage that you have with your governance gates, but it also means that you simply may not know what the scope of things you have to govern is. If you're not governing those things, you don't have telemetry on what kind of defects are being introduced, and therefore you don't know what security risks exist when they're delivered. So that gap is the key thing we have to address. We have to make security a self-service, as is the development process and the software lifecycle overall. So when we look at the different layers of automation, development and engineering have very diligently gone about making sure that each aspect of software delivery, from infrastructure to service mesh to containers to dependencies and open source to application config, is automated. And each of those, and on the left here we have the tools that developers have used to render each of these capabilities on the left something they can just configure declaratively with configuration files. There's a tremendous amount of overlap and ambiguity, but the point is that whichever layer of the stack, and in fact, even if you want to automate the full stack, there's a very rich amount of automation and a very rich amount of as code or as config support for engineer and lifecycle. When you look on the security side, each of the tools that are listed here are they're open source, and I've purposefully selected open source because, again, self-service. What could you, as an engineer who's interested in security, or what, as a security executive, are your engineers availing themselves of? There's pretty scant analog to what we see on the left. Each of these things on the right, from a security perspective, 3 years ago, with the exception of OWASP dependency check, really weren't what I would consider to be GA and sort of well regarded. And even now we're looking at a dozen, 2 dozen security rules inside of these tools. So very scant, very sparse coverage from the perspective of what kind of configuration can be consumed and automatically governed. And then, what you can do as it pertains to covering the security domains that you need to cover. Because if you think about this stack here on the left from bottom to top, there are a lot of different things that you have to consider. Some tools only look at network and perimeter. Some tools only look at identity. Other tools only look at like encryption material and encryption configuration. Others look at code identity. Others look at user identity. There are anywhere, depending on how you count or what standards you follow, from 9 to about 13 security domains that you have to look at. And the configuration for those things is available inside of tools from Chef down to Terraform, but there isn't the rule and sort of the domain coverage over here on the right. That's the problem setup, but there's stuff we can do about that. So let's look at that. We need a mechanism.
Hey, John?
Yeah, go ahead.
Hey John, let me just that's okay. Let me just while we have folks and we're talking about security tools and infrastructure and components and things, let's just launch this second poll here. So this is the second of 2 polls up on the screen now. So what percentage of cloud application releases undergo security reviews of their infrastructure as code before being deployed into production? So based on the last results, I'm guessing, well, I'm not sure.
Who knows about the guess? It may be 25 and 25.
It may be, yeah, it may be. Yeah, it may be. So take another 30 seconds here to answer the question, the poll question. I'll also just reiterate what Brooke said at the start. If you do have a question for John, please post that question in the questions tab on the right of the screen, and we'll get to the questions at the end. I've got about 10 seconds left here, so go ahead and put your final selections in, and okay, I'm gonna close out the poll and kind of see what happens. There we go.
Okay, so oh, I see. There's it's continuing updated. So of the people, there's not as much infrastructure as code adoption in this group as we've seen in prior groups, but where there is adoption, between 25 and 50%, and between and greater, a lot of it is actually governed. And so one of the key aspects of this trend towards self-service is you can start by incorporating into your pipeline as a service or your automation regimes the open source, and that gets people in the rhythm, in the flow of checking their configuration for its security properties, and then you can upgrade either by adding to the IP and the rule base that you're governing against in the open source, or by upgrading to a commercial product if you see fit, for scaling the infrastructure as code. So what are we looking for when we build security as code? So we want to document our security policy and our control objectives as code. Somebody asked in questions, well, what about control tower? What about the generalizing that question, all right, so the CSPs are providing me some automated policy mechanisms, and they've coded those policy mechanisms against things like well architected. That's great. What we see when we study organizations is that more mature organizations are moving away from a solution where they look only at the posture of their runtime environment. They're trying to get to developer self-service by saying, we want a runtime and a postural assessment. We can use the cloud. We can use some of the cloud mechanisms for that posture assessment, but we need to push back into the development process, whether it's build and test there, or whether it's as early as commit hooks to SCM repositories. We need to push back into development, basically spell check for the same kind of security configuration and the same kind of application of security policy that we're checking at posture time. The other thing is that we see a lot of people working through, policy that's not just, well, I need to make sure disk encryption is set to true, but I need to know that customers are managing the keys. I need to only apply that guidance to data disks. I need to make sure the keys are rotated within the policy of my organization or my customers' organizations. Typically, when you look at those multifaceted answers, that's what generates an action on behalf of an engineer or a security practitioner. And typically the cloud provided things like Control Tower can't take a multifaceted approach because they don't know the organizational sensibilities and those particular this particular salt and pepper or herbs to taste. And that's even the case when you look at CIS benchmarks or sort of or the CSA. There's a lot of room for interpretation, and there's definitely a lot of room for organization specific coloration. What we see organizations doing is trying to bake their own risk tolerance as well as their own best practices or standards into the same set of checks that are sort of those single dimensional ones. The other thing is that we want to be able to continuously validate. So if you only look at the posture, it's kind of like slapping a hand on the bad behavior, but the behavior, the deployment has occurred. What you want to do is get back from the symptom to the cause of the error, which is the developer or the engineer authoring the non-compliant stanza of configuration, of orchestration, of cloud configuration. So we see organizations that are forward-looking really driving to automate validation not only of the runtime posture, but translating that validation into the build time checks. And then finally, we see people applying context to that. Not only do you have to express the policy in terms of those what's said on the slide multi-predicate, but those different contextual questions. But many of the questions about whether or not something is an exposure or not depend on organizational or environmental context. So you want to apply different sets of policy to development or staging environments versus prod, because you want to answer questions like, has prod data got to development? You want to make sure that development secrets and artifacts don't get to production. We're also looking at in a situation where each development team is responsible for a different maybe risk tolerance or risk profile. Think about a bank. Bank has retail banking, it has private banking, it has commercial lending, it has retail lending, it has credit, it has mortgage. Think about regionality. Think about service availability. Think about encryption standards. Each one of those security domains is not only contextualized by the development or the development phase context, but also the business unit context. And so there isn't a one-size-fits-all policy for an organization. Instead, there are policies for those sub-organizations. And those conceptual policies that I alluded to there with my comments are going to translate what are the services that you're going to enable for a developer in the private bank versus a developer in the retail bank. How do those, and then they're also typically, because nobody short of a Netflix or an Amazon is necessarily starting whole cloth in the cloud, they're typically going to rely on services from the CSP, third-party services, and then services from whatever the data center is. And so the allowable service list and how you think about security and privilege will be multi-part. It'll be, well, you can use these kind of services from our CSP, and these are the kind of services that we have in maintenance mode that we will allow you to connect to. You can connect to underwriting, you can't. and so on and so forth. And this is another place where sometimes the cloud native solutions on posture and policy fall short because they don't necessarily have rich support for the kind of data center and other interconnects beyond things just like tagging, which is how some businesses deal with it, but not many. Finally, when you begin to treat your security governance regime like code, and you start to configure it declaratively, then what you quickly realize is that you have a first cut at it, and that first cut gets divided and skewed, into the different business units and contexts, and you realize you improve it over time. You improve it over time because you learn more or adopt new tools that help you detect or protect or conform. You learn more about what your risk tolerances and your compliance demands are, or because you're ratcheting down the governance regime, going from loose to tight as people become compliant. If you're a security initiative that's coming from an emerging to a growing or maturing maturity level, then you do measures and metrics based on how many violations per unit, per team, per line of code, per release. Those measures cannot be reliable metrics or KPI unless you're versioning the test that develops those metrics. And you need to be able to assert that if, a 4 on your risk index becomes a 5, that it's because you increased the number of tests in the regimen or because they got worse and regressed. You can't do that kind of measurement analysis, and you can't do that kind of management from a security perspective unless you treat your governance regime like software, like you do your other software, and measure it. And so when we begin to think about security as code, we have to do all the other things we do to code. We have to develop it, we have to test it, we have to version it, we have to manage it. That may sound daunting, but it's something that you can handle incrementally. You can begin to codify this stuff, you can begin to enrich it, you can begin to roll it out as automation, you can apply it in the right context, and you can version it, and you can do these things iteratively. And what organizations are finding, another challenge with the open source, or another challenge with the CSP managed tools, is they take a prototypical view of some of these features and say, we'll give you the opportunity to look at our native functionality this way, and we won't give you the contextualization, and we won't give you the lifecycle management. What we see people doing, and this is directly as a result of the BSIMM studies, we see people moving from, and you can't see my mouse. Okay. What we see people doing is we see people moving from a place where, at least in the prior regime of application security and network security, they were looking in production and doing production scanning from a network and infrastructure perspective. And they were spending a lot of time building and augmenting tools in their CI/CD environments for analyzing the code. We see people moving to two different spaces. They're moving from build and pipeline and from post-production scanning to they're moving from the pipeline back to SCM. And they're moving from the pipeline actually right to artifact and repository, and looking at the way that systems and service meshes and applications are built out of containers and of orchestration configuration. If what we said is true about the amount of the software stack and the hardware stack that's automatable and orchestratable by orchestration technologies, then this concept of shifting left, to get into the build from testing is a little bit antiquated. And we have to shift to all of the different places that software lives. And the best two places in my mind for software and configuration of assets to find those things and to apply telemetry to them is get them at the source where they're checked in, as the developer commits them and shares them with other developers, and look at where they are committed or where from they are orchestrated as you begin to build the assets that are delivered and orchestrate the combination of those assets from containers to running systems and from running services to full systems. And so what you'll see is that people are moving from a do testing during pipeline and build, and then do testing in a post-production environment to find the code and shift everywhere to where the code is first seen. And the two places where the code is first seen is when it's committed to repositories, or when it is committed to or used as orchestration or construction or constituency specification for containers and service meshes, or running system configurations, service mesh or Kubernetes configuration. So if you're an organization that says shift left to get earlier about our security, governance, and scanning, I would challenge you, don't shift left, shift to everywhere the code is, and recognize that the code is moving right as more and more of infrastructure is becoming self-service and software defined. Organizations that have matured and really embraced this model are now looking at sort of three phases. Left of the build in terms of the commit, right of delivery in terms of guardrails, and then right of boom. In other words, when an incident happened or while it's happening, and they're looking for ways to correlate those three different phases with the engineer that's responsible for the artifact that was either exposed or shown vulnerable. The dynamism of our environments and the self-service of previously fixed or hardware-based assets like infrastructure means that we can't just shift left, and we have to shift to everywhere, as I've just sort of pressed upon. If we only look at CSPM and we only look at guardrails or enforcement, then we really struggle, having moved right, with attribution. In other words, we really keep focusing on the symptom and blowing our nose, as opposed to figuring out that we needed a Claritin and prevention. And so organizations that have historically over the last 3 to 5 years shift far right to a guardrails or a enforcement perspective are really struggling to recreate the links back to the different configuration and code that those result in. And then safely navigating to right of boom, or a situation where you can attribute from an incident that's occurring or that has occurred, is a sign of very high maturity. We'll get to that as we look at measures. When we do cloud security well, we focus on what I'll call the emerging center. And the emerging center is the ability to combine telemetry from running systems, how you packaged those running systems with container, image registry, marketplace, and orchestration, and service mesh, with stuff from the left, what you're committing and what teams are sharing in terms of code. Because people are committing more and more of their artifacts to SCM, and we'll get to this later, what it means is that attribution is easier. Finding the engineer that has permission to see the source and improve it, or remove the cause of the symptom is easier. When you take the approach that when you take the approach that you're going to try to instrument that center and collect information from those different environments, then you have the opportunity to begin to change metrics from things like, well, I have this many vulnerabilities per release, I have, this many defects per scan. You get away from those, historically security metrics, and you can start to answer questions like, all right, how quickly, how quickly am I able to respond to change? And how is security a net enabler to, or a disabler for, increasing my rate of change into production? Some of these resilience-based metrics are extremely mature, and if this audience is one that is exploring infrastructure as code, these may be foreign metrics to you. These are metrics that likes of Intuit, Etsy, Netflix, others have gotten very comfortable working with, saying that, look, we do a bunch of different kinds of security governance. Some of that governance is asynchronous. We're constantly deploying, and we're tracking how long it takes us to get from a point of visibility, and then to a point of security from what we've seen. And so they can talk about resilience, rollback rate, and other things. What I would suggest looking at, in the short term, is the stuff on the left. How long is it taking you to get to a point of approval and delivery? Working with an organization right now, it says, look, our main problem is that developers want to stand up cloud-based development environments, and it takes 3.5 weeks to approve them. That doesn't work for us because we want to continually stand up delivery capabilities, and we want to deliver, on an hourly or on a daily basis. If it takes 3 weeks to get an instance approved, then security is really delaying us. Can security get to a point with, defining those environments with Terraform, tagging them correctly, figuring out what services or regions or other things are necessary for a business unit, and get to a deployment time for development environments that is commensurate with that self-service desire, so that either the checking of those environments against policy and security standards is either automatic and instant as part of their orchestration through a Terraform file, or is at least facilitated through automation. Same thing with deployment frequency. Are we able to deploy continuously because we're applying our standards to the files that we use for deployment, and applying our security governance to them? Start with those measures, and when those measures are acceptable and security has achieved a level of cadence that is commensurate with development and delivery, then you can move to resilience, and you can say, actually, I'm fast enough at detecting and responding that I can afford to do it entirely asynchronously with my delivery. And that's where you get into the resilience rollback rates, time to patch and time to recover. The chief challenge in codifying policy that allows you to drive to these measures is subject matter expertise. Each of the CSPs is idiosyncratic. Each of the CSPs is... Tony, I'm getting some background noise from you. I don't know if you can go on mute for a second. Oh, I can mute you. Haha. Okay. Thanks. Sorry for the distraction. Where was I? The challenge that most security organizations have is, even if they have a tool that allows them to provide this governance, they're struggling to understand the scope of services that a chosen CSP has today, let alone multiple CSPs, and the rate of change that's promulgated by each of the CSPs. If you don't have a way to translate what you know in English or in your mind you want to apply in terms of security policy to the kinds of things that the actual technical controls and checks will have to validate, that's a struggle. On our Concourse platform, we've built authorship tools that try to convert this problem from a subject matter expertise drag to something where basic cloud literacy suffices. And so with autocomplete and ingesting the CSP's type systems, and the way our UI presents information to the user, we hope that, template policy and then specific policy is immediately auditable, and immediately auditable, to the user in a way, that makes sense to them, so that, you can see what kind of policies are available. When you click on the policies that are available out of the box, you can see what they entail. And you could quickly, edit those policies and have autocomplete associated with them, so that, on instances what values you have, and what you can do with those. We think that particular kind of enablement is essential, because a lot of this in black boxes becomes sort of inscrutable voodoo. And what you really want is template policy that is, again, auditable, and that you can quickly change to match the needs of either your business unit or your development phase environment, or similar. I'm going to jump back to this, but you also see evidence. Well, I'll get back to that in a minute. Somebody asked, I think, in the questions, and I'm trying to audit these and incorporate them as we go. Our platform contains CSA CCM mappings, CIS mappings. Compliance is a great driver for security, but compliance does not make you secure. So best if you can encode your security controls and checks into a platform, or use those that come out of the box. Once you're using those, it really saves you a lot of time when the platform can show you where you have exposure or risk, and then mentions the compliance reason why you'd fix it and generates a compliance report. So being able to manage your mappings to either industry standards that you're using for compliance from team to team, or to your best practices. We're seeing a trend when we look at firms where a CTO office is using architects to drive a best practices or a security standard, or an approved policy set or tech stack, and then literally changing the software lifecycle based on whether or not you conform to it or not. It's called fast lane, slow lane. Being able to encode in the platform that you're on your organization's fast lane, that you're using the infrastructure as code that's approved, you haven't changed it, that it's compliant with that set of best practices. Maybe you don't have to go through a thorough design review before you deploy to dev. Maybe you don't have to go through a thorough test before you deliver to prod. Being able to encode those catalog standards, that are either industry provided or that your organization's provided, is essential to making sure that culturally it's adopted and driven. Before I get to the demo, I want to talk to questions, and I want to mention this. Here are some things you can do today, right? You saw the you saw this slide. I would say make this slide for yourself. Build a matrix of what kinds of ways engineers are automating both the development as well as the delivery and operation of software. Remember that code is shifting, right? And that you're going to need a way to govern the security posture of all of that code, whether it lives on the left or whether it lives in this right. And think about each of those layers, because your posture is like a bunch of china sitting in a precarious stack on your dining room table. If any of the layers of that stack are vulnerable, you're challenged. So you need to make sure you have a security check for each layer of that stack. You want to pair a software-defined capability that engineers are using with an automated way to evaluate, an automated way to apply controls, or some combination. I like a belt and suspenders approach, doing enforcement and fix along with prevention. Enforcement and automated fix is getting a lot of press right now, but we see more mature organizations saying, we're not going to rely on that. We're going to drive back to a preventative model. We want the developers to fix what's causing the symptom, because ultimately we're concerned about the side effects of automated fixing. And that's bitten our organization and others to a point where it's really reinforced the need to be preventative. We can iteratively encode positive and negative guidance. Positive guidance is security frameworks, security controls. Negative guidance is exposures and violations. And as we iteratively, apply those things, we need to version that so that we know when we're measuring organizations and engineers, we know when numbers go up or down, whether they're going up or down because the test got harder, because their code got worse, or some combination of them. And we need to implement, whatever's easiest, the best practices or the violations. Aggressively integrating with DevOps initiatives or pipeline as a service initiatives represent the brass ring that every security practitioner and executive should be reaching for. If your organization is trying out GCP and looking to migrate to that, and you're building pipeline as a service around that prototypical GCP usage, then putting the security checks in that prototypical service and pipeline is essential. Think of it as a train that's leaving the station. If you put the security controls and the scanning into that train, then everywhere it goes, every ephemeral pipeline that's created based on it gets governance. And you don't suffer the challenge, the overwhelming avalanche of effort associated with finding, inventorying, missionary work and integration. I already mentioned belt and suspenders a few different ways and a few different times. Finding a way to automatically fix or enforce these things is dealing with the symptoms. We're seeing the most mature organizations push to a preventative strategy and convert those checks, maybe that begin as runtime postural assessments, into what the source artifact was and what fixes need to apply to it. And when we hit the train and get on the train of integrating those controls into the pipeline as service initiatives, we automatically enroll all new, even ephemeral assets in the governance regimes effectively. So I want to show some of the features, that the Concourse platform drives at. But I'd like to invite people to ask questions and invoke discussion through the chat as I do that. And that way we can look at what our platform does to meet some of these needs while we're addressing what may have not come up or what may have come up in your mind that you haven't asked. I tried to answer the questions that are already present. What I will say as I demo is one of the things that you'll see when this works well is the following modality. People will come into a platform like Concourse. They will look at the existing policy groups and what is out of the box. They will see things like, the CSA policy, and they'll say, this is a great start for me. They may choose to edit this policy that comes out of the box inside this UI with the authorship tools I described that help them. They may just look at this and audit it and see that it meets their needs. We have some forward-looking organizations that take the time to download this as JSON, and in pursuit of answering the question, can we integrate this with engineering efforts? Can we create pipelines as a service? What they will do is take those downloaded resources and they look just like code. Again, it's security as configuration. The policy is the configuration, it's executable. They'll commit this along with repo templates for the pipeline as a service. They'll provide hooks to the SCM platforms so that when people begin to author their own environments using things like RDS, you see that those things are covered by this policy. And when commits occur, you see that there's that these things will immediately begin to create breaks, and people will say, well, I've got non-conforming resources, and they can come back here inside the platform and see not only what happened, but what to do about it. By allowing export of security policy as configuration, by integrating directly with the SCM platforms, and by giving the developers the ability to see the test next to the test they're taking as they write their code or as they apply those templates, you're not allowing the wolf to watch the hen house. Instead, you're allowing them to code to the test, which is what you want. You want them to be compliant. If development groups are innovating rapidly, they're going to change what kind of services, what kind of regions, what kind of things that they're doing. And what you will see is when they do that, a platform like Concourse will see that they have taken the standard being applied automatically through those commits. And you will see that, well, actually, there has been a change to the policy being applied, and this engineer changed it, and here's what they changed. And in that way, what you're able to do is not only integrate with the DevOps pipeline as a service mechanisms, but you're giving the developer agency. If they make the changes, you're seeing in the security platform what they've done. And as a security practitioner, you don't have to go out and find an inventory and evaluate. You only are presented with either critical violations of your policy, which drive a slow lane behavior and perhaps gating, or you see that the developers have changed the policy because the baseline policy didn't work for them, and it invokes a conversation between security and development organization as to how to accomplish update of the blueprint and the standard or the policy, or update of their environment to comply to it. When you end up in a situation where security is on the security platform and development remains in their lifecycle tools and platforms, and both are working on their side of the river, but they can collaborate across that colostrum, then that's when you're going to be able to move at development speed from a security perspective. I don't know, Tony, I don't know, Brooke, if we've seen any questions in the interim time, but if we haven't, I really appreciate people's time and attention. This is actually a very exciting time to be in security because, again, with the kind of development and delivery scaffolding we see, we actually can achieve the level of automation that we've always dreamed of. What it means for us is that we have to be willing to encode our policy as code, and we have to be willing to commit it to our engineers' platforms and pipelines so that it's applied automatically.
That's great.
Will totally change the physics of your environment. Sorry, Tony, go ahead.
No, that's great. Thanks, John. No new questions have come in since the ones you've answered. So we're almost at the top of the hour. So I'll just pass it over to Brooke to close this out.
Awesome. Thank you so much, John. That was great. Thank you so much for presenting. And Tony, thanks for organizing and sponsoring the webinar. For those watching, down below the presentation screen, you'll find a tab to rate the webinar. We'd love if you can review today's webinar so we know what content you're enjoying. And right next to that, you'll find several different resources from today's webinar in the attachments section. If anybody has any additional questions, please reach out to the CSA research team at research@cloudsecurityalliance.org, and I can get you connected with today's presenters. You'll also be able to watch this recording within minutes of the conclusion by using the same link to rewatch. Thank you guys for attending and sponsoring this webinar, and have a wonderful day.
Thank you.